Good morning, students. So in the last video lectures, we learnt about the types of matrices, characteristic equation of a matrix, eigenvalues and eigenvectors of a matrix. And in this video lecture, we are going to learn Cayley-Hamilton theorem and the use of Cayley-Hamilton theorem, which is nothing but inverse of a matrix. The use of Cayley-Hamilton theorem is to find out the inverse of a matrix. So, and similarity transformation. So, we are going to learn today Cayley-Hamilton theorem and inverse of a matrix by Cayley-Hamilton theorem and similarity transformation. Cayley-Hamilton theorem, which says about it has to satisfy its own characteristic equation. So, we know that how to find out the characteristic equation of a matrix we know already. Eigenvalues, eigenvectors, all those things we learned earlier. So, Cayley-Hamilton theorem says that it has to satisfy its own characteristic equation. So, Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. In a simpler term, if you have a square matrix, this will work out only for a square matrix. If you have a square matrix A and calculate its characteristic polynomial in terms of lambda square, lambda cube, a polynomial derived from A, and then substitute the matrix A back into the polynomial, the result will be a zero matrix. That is, instead of lambda, you substitute A, and it has to satisfy its own characteristic equation, its own equation. Ultimately, we will get the answer as 0. So, what are the applications? So, as we said earlier, we will have to find out the inverse of a matrix is the main application. So, finding the inverse of a matrix. The theorem can be used to express the inverse of a matrix as a polynomial in the matrix itself. Other main application is we can calculate the powers of a matrix. For example, A is given, we can calculate A cube, A to the power 6, A to the power 12, or even A to the power 33, 35, and so on. So, we can get the powers, high powers of a matrix. So, the main applications of Cayley-Hamilton theorem, one is the inverse of a matrix, and second one is the high powers of a matrix can be found out. So, every square matrix satisfies its own characteristic equation is nothing but Cayley-Hamilton theorem. We know that for any matrix, the matrix elements are given as this. So, let the characteristic equation of the polynomial is given by this. We are going to use this formula A minus lambda I, and of course we will be getting this matrix. So, this is a characteristic equation A minus lambda I determinant, which is equal to 0. We have the characteristic equation depending on the order of the matrix. But here in Cayley-Hamilton theorem, lambda is replaced by A. So, wherever you find lambda, we are going to replace lambda by A. It should satisfy this characteristic equation. We will solve one problem, then after that we will come to know how to use Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem for the matrix. So, this is 2 by 2 matrix. So, matrix A is given as 1 minus 1 minus 6 minus 2. So, A is given as this. Okay. So, we will solve one problem using Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem for the matrix A equals 1 minus 1 minus 6 minus 2. So, A is given as this matrix, and of course we know the characteristic equation is given as det A minus lambda I equals 0. So, use that equation into the matrix, we will be obtaining this 1 minus lambda minus 1 as it is, minus 6 as it is, here alone minus 2 minus lambda equals 0. So, take the determinant. So, 1 minus lambda multiplied by minus 2 minus lambda, this multiplied by this with a minus sign. So, minus 1 multiplied by minus 6 will be plus 6, already one minus is there, so minus 6. And of course, simplification, we will have this 1 multiplied by minus 2, 1 multiplied by minus lambda multiplied by minus 2, that will give you this minus into minus plus, so plus lambda squared minus 6. So, you have lambda squared, then minus lambda plus plus 2 lambda will be plus lambda, minus 2 minus 6 will give you minus 8. So this is your characteristic equation. Now Cayley-Hamilton theorem says that lambda is replaced by A. So lambda is, wherever you find lambda, you replace with A. So you have A squared plus A minus 8i equals 0. So Cayley-Hamilton theorem says that it has to satisfy this equation, this characteristic equation. Now A squared plus A minus 8i equals 0. So now you just find out, this is the equation. So first we will find out A squared. So A squared equals A multiplied by A. So this is your A, original A. See, this is your A. So A multiplied by A. So A multiplied by A will give you this, correct? 1 multiplied by 1 and minus 1 multiplied by minus 6 will give you this. So similarly other elements. Simplification, you have A squared equals 7, 1, 6, 10. So in this equation, so A squared, we have found out A squared. Our left hand side will be your A squared plus A minus 8, correct? A squared plus A minus 8i. So just to simplify, 7 plus 1 minus 8. 7 plus 1 minus 8. The next one will be 1 minus 1, 0. 1 minus 1, 0. So 7 plus 1 is 8. 8 minus 8 is 0. 1 minus 1 minus 0, again 0. Here also you will have 0 and this will also. So it satisfies, see here, right hand side you have 0. It satisfies its own characteristic equation when you are going to replace lambda by A. So this is, thus Cayley-Hamilton theorem is verified. Now consider equation 1. So this is equation 1. So A squared plus 8 minus 8i equals 0. We are going to find out A inverse. So as we discussed earlier, the use of Cayley-Hamilton theorem is to find out the inverse of a matrix. One can find out the inverse of a matrix using Cayley-Hamilton theorem. So A squared plus A minus 8i equals 0. Just multiply on both sides by A inverse. A inverse. So A inverse A squared will be A, correct? A inverse A squared. So A squared divided by A will get cancelled. So one A will be left out. So A. Then A inverse will be identity matrix I, C plus I, minus 8 A inverse, which is equal to 0. Our aim is to find out A inverse. So you bring this term to that side. So you have 8A1. You just keep as it is. So you have A plus I. So A inverse will be 1 by 8 times A plus I. So A inverse equal to 1 by 8. So A, what is A? A is a given matrix plus identity matrix. You add these two and divide by 8, that will give you A inverse. So when you are going to add these two, that will give you 2 minus 1 minus 6 minus 1. So dividing by 8, that will be your inverse of a matrix. Any doubt? So one can find out the inverse of a matrix using Cayley-Hamilton theorem. So we will go for now 3 by 3 matrix. So earlier we discussed 2 by 2 matrix. Now we will go for 3 by 3 matrix. What is asked? We are going to verify Cayley-Hamilton theorem and we are going to compute A inverse, the same process. So we are going to find out the characteristic equation first. So A minus lambda, det lambda I equal to 0. So this is where A, det A minus lambda I. So 2 minus lambda. Here also we have 2 minus lambda, 2 minus lambda. Other things not, let it be like this. So which is equal to 0. So we will obtain the characteristic equation exactly as it is. That is your assignment. How to find out the characteristic equation? So you will have to take the determinant. So 2 minus lambda multiplied by 2 minus lambda multiplied by 2 minus lambda multiplied by this. So minus 1 multiplied minus 1 with a minus sign. So you have minus 1. So similarly, you will have to take the other element. You will have to take the other element. You add all those things, that will give you this equation that you know already. So that will be your assignment. Now Cayley-Hamilton theorem, you will have to replace lambda by A. So lambda by A will give you this. Correct? So just calculate. Now we will go for first A square. So A square. This is your A and this is your A. So matrix multiplication will give you this answer. Simple. 2 multiplied by 2 minus 1 multiplied by minus 1 will be plus 1. So 2 plus 1. 1 multiplied by 1 will give you 1. So 2 2s are 4. 4 plus 1 plus 1 6. So you have 6. Similarly, other terms. Minus 1 multiplied by minus 1, then no. 2 multiplied by minus 1 multiplied by 2, then 1 multiplied by minus 1 will give you minus 5. Similarly, other terms also can be obtained. Now, what is a cube? How to find out a cube? Because a cube is here. So, how to find out a cube? A cube will be a squared multiplied by a. A squared already we have found out a squared. So, a squared is here. Multiplied by a. So, matrix multiplication. So, this multiplied by this will give you this answer. So, we have found out now a cube. So, a squared also we have already found out. A cube also we have found out. Already a is there. We can substitute. Whether it satisfies or not, we can find out. So, the characteristic equation is a cube minus 6a squared plus 9a minus 4i equal to 0. So, a cube is this one. Already we have found out a cube. So, substitute for a cube minus 6 a squared plus 9 a is here minus 4i. You add all those things will give you 0. So, right hand side is 0. It satisfies its own characteristic equation. Okay. Now we will have to find out A inverse. Okay. So, this is the characteristic equation. You multiply on both sides by A inverse. You multiply on both sides by A inverse. So, we have multiplied by A inverse will give you A squared. Correct. A cube multiplying on both sides by A inverse, as I said. So, A inverse A cube will be A squared. Minus 6a squared multiplied by a inverse will give you 1a. So, minus 6a plus a inverse will be identity matrix. So, I minus 4 a inverse equal to 0. Our aim is to find out a inverse. You just bring this term to that side. So, that will give you 4a1. The remaining term, let it be like this. So, you have 4a1 which is equal to a squared minus 6a plus 9i. So, a squared already we have found out a squared, correct? Earlier. See, we have a squared here. See, already we have found out a squared. You substitute for a squared. Okay, this is your a squared minus 6a plus 9i. So, add all those things, that will give you this matrix 3 1 minus 1 1 3 1 minus 1 1 3. And of course, your 4a1 is on the left hand side. So, a inverse will be 1 by 4 times this matrix. So, that is your inverse of a matrix. So, we have verified the Cayley-Hamilton theorem and we have found out the inverse of a matrix, A inverse. Now, we will go for another problem. So, given that the matrix is given as this, we are going to find out adj A by using Cayley-Hamilton theorem. We are going to find out adjoint A. Okay, adjoint A. Adjoint A is nothing but the transpose of the cofactor. What is the cofactor of 1? The cofactor of 1 is this multiplied by this minus this multiplied by this. Simplify. That is your cofactor. And with the symbol, very important, with the symbol. So, this will go with plus, minus, plus, minus, plus, minus, plus, minus, plus. So, you have to use the symbol also. Cofactor, the transpose of a cofactor will be your adjoint of the matrix divided by det A. Okay. We will find out. First, we will find out characteristic equation of the matrix. So, A minus lambda I equal to 0 and this is your A minus lambda I equal to 0 and we can find out the characteristic equation exactly like this. So, 1 minus lambda multiplied by times 1 by lambda multiplied by 1 by lambda squared. See here 1 by lambda squared. Then minus 1 multiplied by minus 1 plus 1. 1 minus is there, so minus 1. And you can go for this side. Instead of going for this side, you can go for this side. So, the second term will be 0 and third term will be 3 times. See here 3 times. This multiplied by this multiplied by this multiplied by this minus. So, minus already 1 minus is there, so this becomes plus. Okay. Now, simplify. On simplification you have this expression. So, 1 minus lambda you just simplification, just we will simplify. So, you have 1 minus lambda whole square will be 1 plus lambda square minus 2 lambda, this minus 1 is there and 3 and here you can do it like this, minus 2 multiply plus 1, that will give you minus 1, so minus lambda 3 times. So you have 1 minus 1 will be 0, so lambda square minus 2 lambda 1 minus lambda multiplied by 1 minus lambda. Simplifying this will give you this. So after that just multiply with 1 minus lambda with this, you will have this equation, and simplifying you will have this equation, and at the end multiplying with the minus sign will give you this. Okay, so you have minus lambda cube plus 3 lambda square minus 5 lambda minus 3 equal to 0. Just multiply with the minus sign will give you this. So this is your characteristic equation. So we will have to replace lambda by a using Cayley-Hamilton theorem. So this is the characteristic equation, and we are going to replace lambda by a. So that will be your this Cayley-Hamilton theorem. Now just multiply with a inverse. So multiply with a inverse will give you a inverse multiplied by a cube will be a square minus 3a plus 5y plus 3a1. So you just keep 3a1 this side, you bring all those terms to the right hand side, will give you 3a1 which is equal to minus of all those things, minus of this thing, and of course a inverse will be 1 by 3 times of this. So you have a square term is there, so you have to find out first a square. So a is multiplied by a, matrix multiplication will give you this. So we have found out now a square, and 3a is 3 times of a. Okay, and last one is 5y. So 5, last one is 5y. So you have now a square minus 3a plus 5y times minus 1 by 3. So times minus 1 by 3. So just add all those things will give you this. So minus 1 by 3, that will be your a inverse. Now as we discussed earlier, adjoint we will have to find out adj a. Adj a is, as I said earlier, cofactor, transpose of a cofactor. Okay, now with the sign, now there's a formula to find out a inverse which is equal to adj a by det a. A inverse equal to adj a by det a. What is the problem? We will have to find out adj a. Adj a only is asked. So cross multiply, we have already found out a inverse, we know already det a. Cross multiplying will give you adj a. Adj a will be a inverse multiplied by det a. A inverse already we have found out a inverse. Det a we will have to find out only det a. Okay, that's all. So we can find out det a. Det a is easy to calculate. So as usual we will have to find out det a here. So we have found out now det a. Adj a equals a inverse multiplied by det a. So adj a equal to a inverse. So this is your a inverse. See here minus 3 a inverse, and this is your a inverse. No, this is your det a, and this is your a inverse. See here adj a equal to a inverse. We have found out a inverse multiplied by det a. So this is your det a, and this is your a inverse. So 3 will go off, minus minus plus, and this will be your adj a. Okay, now how to check whether we have done correctly or not? So now a, this is another method as I said discussed. So a is given as this. Adj a is nothing but the transpose of a cofactor. So transpose of a cofactor we will find out first. What is cofactor? You just leave this one, 2 multiplied leave this one, 1 multiplied by 1 multiplied minus 1 multiplied by minus 1 plus 1 minus that, so 1 minus 1 0, so 0 is. What is a cofactor of 2? 0 multiplied by 1, then 3 minus 1, so plus 3. I told you with the minus sign, so here there will be minus sign, so minus 3. Is it okay? Similarly cofactor of this will be minus 3. What are the transpose? Just transpose row into column, column into rows, rows into column. So 0 minus 3 minus 3. See, rows into column. This is exactly equivalent to this. So this is your adj a. So adj a, this is how to check. So we can check already whether the answer is correct or not using this idea also. Okay, any doubt? See, both are the same. Now we will go for some other problem. A square matrix satisfies its own characteristics, nothing but Cayley-Hamilton theorem. Let us solve. A equals 2, 5, 4, 1. The characteristic equation is given as det A minus lambda equal to 0. So det A, this is your A minus lambda I. Simplifying, you will have 2 minus lambda, 5, 4, 1 minus lambda. Cross multiplying will give you this minus 20 equal to 0. Simplifying, you will have the characteristic equation for the matrix lambda squared minus 3 lambda minus 18 equal to 0. So by Cayley-Hamilton theorem, lambda is replaced by A. So A squared, this equation becomes A squared minus 3A minus 18I equal to 0. So you have to find out first A squared. So A squared, A is given as this. So A squared is this. So A squared 2 multiplied by 2 plus 5 multiplied by 4. See, and we have 24, 15, 12, 21. So just a substitute here. So we have A squared minus 3A minus 18I. So this is for A squared minus 3. A is here, 18I is here. You just simplify like this. You will get 0, 0, 0. So it satisfies its own characteristic equation. Thus the Cayley-Hamilton theorem is verified. Cayley-Hamilton theorem matrix for 3 by 3. Now A is given as this. So we are going to verify Cayley-Hamilton theorem. So A is given as this. So A minus lambda I equal to 0. So A minus lambda I. So this is where A minus lambda I. And we have 1 minus lambda, 2 as it is, 3 as it is. And this term will become minus 1, minus 1, minus lambda. And the last term will be minus 1, minus lambda. So as usual, we will have to multiply this by this with a minus sign. So now we are going to go with some another method. Which method? This equation already we know this equation, lambda cube minus s1 lambda square plus s2 lambda minus s3 equals 0. What is s1? S1 is the sum of main diagonal, trace of the matrix. So trace of the matrix will be 1 minus 1 minus 1. See, that will be minus 1. What is S2? S2 is nothing but sum of the cofactors of the diagonal elements. Sum of the cofactors of diagonal elements. Sum of the cofactors of diagonal elements. So this is your cofactors of diagonal. Minus of, can you remember, minus of main diagonal elements, which is nothing but your S2. S2 is nothing but minus of main diagonal elements. So these are all main diagonal elements. You have to find out the minus. See, these are all minus. Or otherwise we can say sum of the cofactors of diagonal elements. Either way. So after finding out, you will have minus 18. So S2 is nothing but your minus 18. S3 is nothing but det A. Determinant of A. So you have determinant of A can be easily found out. So determinant is nothing but 40. So use this equation, lambda cube minus s1 lambda square plus s2 lambda minus s3 equals 0. Substitute the values of s1, s2, s3. You will have the characteristic equation exactly as it is. Now, according to Cayley-Hamilton theorem, lambda is replaced by A. So this equation becomes A cube plus A squared minus 18A minus 40I. I is missing. So 40I equals 0. So you have A squared. First we will find out A squared. A squared, A multiplied by A. Matrix multiplication. A multiplied by A will give you A squared. 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 3. So you will have this. Okay. So now A squared we have found out, now A squared. Simplification, you will have A squared here. The next one will be A cube. A cube is A squared multiplied by A. So your A squared multiplied by A will give you this. So your A cube is this matrix. Okay. Now A cube plus A squared minus 18A minus 40A equal to 0 is the Cayley-Hamilton theorem. So your A cube is here, A squared is here, minus 18, A is here, 40I. So simplification, you will have 0, 0, 0. So 0, 0, 0. Thus the Cayley-Hamilton theorem is verified.